Hello student. Today's topic is the interference of light and the Young's double slit experiment that we will see today. First, let us see what is the interference of the light. Interference of the light means when the two light waves of the same frequency and having the zero or the constant phase difference traveling in the same direction superpose each other. The intensity in the region of the superposition get redistributed, becoming the maximum at some points and minimum at the others. This phenomenon is called the interference of light. Means, as I already told, that suppose the two waves are there, that is generating S1 and S2, that is generating here, and they reaches to a point at P. This wave comes traveling this path and this wave comes traveling this path. So since both are generating from the coherent source, as I already said, that is the coherent source. Coherent source means whose frequency is the same. Coherent source means same frequency. And so there is no phase difference should be there, but when these waves traveling the different distances, so the phase difference we are getting at the point where they are reaching, because due to the different path lengths, because as you know that delta phi, that is the 2 pi by lambda into delta x. X is the path difference and this is the phase difference. So phase difference causes due to the path difference only, that is delta x. As I said, suppose the x1 and this path length is x2, so obviously there is a difference and due to this difference only the phase difference you will get. If they are, suppose I have chosen a point line joining these two slits and we are chosen a point at the midpoint, means from here, from this red color pen I am showing, from this distance and from this source, the distance, both the distances are same, so then there should not be any phase difference, because in this case delta x is equals to 0, so no path difference, so here the phase difference will also be delta phi will also be 0. It means both will reach at the same phase. And again for the next point, suppose this is the P1 I am taken, that was the P and this is P1. So again there is a path difference, because this distance and see that this distance, there is a difference in their path. So again here you will get some delta phi, means phase difference, you will get some value you will get over there. So this is the main cause of the interference of light. Interference of light means we are taking the same frequency waves, है means from the coherent sources and all, but if the path difference between them is the 0 or the constant phase difference, means path difference is 0, phase difference will be 0, or the same or a constant phase difference is there, that is always there, then where they will superpose, means here they are superposing, here they are superposing, means they are mixing with each other, their effect shows on this particle over there, and these are the SHM, simple harmonic waves are coming, they are hitting this particle, and then this particle, these waves are coming and these waves are hitting, then this particle start to execute the SHM. This wave start to execute SHM. So at that case, due to the path difference, the intensity of the light or the sound wave will get the different and this, due to the different intensities at these point, some points we are getting the maximum brightness or the high or loud sound, or the minimum brightness or minimum intensity, means minimum brightness, a dark fringe, or the low sound. This phenomena is called the interference of, if light to then light, a wave, if sound wave to then interference of the sound waves. So this phenomena is called the only interference. Either if it is for the light, so then it will be interference of light. If it is the wave, then it sound wave, then it will be the for the sound. Now let us see the experiment which I told you, Young's double slit experiment. In this Young's double slit experiment, what to do? We will take a main source of light, which is the coherent source, means which is a monochromatic light source, and from there you can see one slit is over there. Slit means a very small hole plate from which the light can come out, and in front of that we have placed the two other slits which are at the same distance from this. When from S to S1 and S to S2, the distances are same, means they are reaching in the same phase, and then from here only they are just producing the new light wave sources, and then these waves are reaching to the screen over here, and at the different point you can see the different intensity light waves you are getting. Means at the midpoint, as I have shown in this figure, that this point is the midpoint where they are reaching with the same path, means traveling the same path, so no path difference is there. So here you are getting the bright fringe, then the dark fringe, then the bright fringe, then this side also the dark and the bright. This dark and bright fringes are causes due to their path differences, as I already told you here. Now you can see through the graph also. This is the called double slit experiment because the two slits are there, that is why. So where the waves are in the same phase, you are getting the most bright fringes over here, because the resultant displacement of y is maximum, and in this case also the same. But here you can see in these two cases they are in the opposite. One wave is going this way, another wave is going this way. So these two waves are in the opposite phase, so they are neutralizing each other, cancelling each other. So you are getting the low intensity, means minimum intensity, it means the dark fringes over there. Here their waves are in the same phase, so maximum you are getting, and here in the opposite phase, so you are getting the dark fringes. So in this double slit experiment we will get the central fringe is always the very bright. The reason is that because the distance traveled from this S1 source and from this S2 source, both are same, no path difference, so you'll get the bright fringe. And then afterwards, why we are getting the alternately bright and dark fringes, let us see. So first of all, you should know that how many types of the interferences are there. There are basically the two type of interference, which one is constructive interference, when the maximum intensity of the light or the sound waves you are getting. Since we are talking about here the light, so we will discuss that only. And next is the destructive interference. Destructive interference means the minimum intensity of the light, where you are getting the dark fringes over there. Now let us start with the constructive interference. where the what is the constructive interference? Where the intensity of the wave is maximum. And as you know, the resultant intensity for the interference, you will getting this and in this the resultant intensity depending on the cos phi value of the phi. And what is phi? Phi is the phase difference, as I already told you. Here it is the phase difference, this, and you are getting by this formula only. So let us see for the maximum value of the cos phi, we know that cos phi is maximum value plus 1. So we will get plus 1 when phi is equals to 0, 2 pi, 4 pi, etc. Suppose we has taken the part difference between the two waves, that is the delta x. So as per the formula, 2 pi upon lambda into part difference is equals to phase difference. So we will put the different values of the phase differences between these two waves, and accordingly we will get the part difference of the waves in these conditions. So first we are just putting the value 0 over here at place of phi. So what we will get, 2 pi upon delta x equals to 0. That I am showing you here. That is the 2 pi by lambda into delta x you want, that is equals to 0. So delta x will be 0. So you got that first one. Now the second one you just see, 2 pi by lambda into delta x is equals to, next is the 2 pi. For phi it is the 2 pi. So when you will put the 2 pi, you just see 2 pi and 2 pi is cancelled out. So delta x will be equals to lambda. You got the lambda. Similarly, you will put phi 4 pi. So that is the 2 pi by lambda into delta x is equals to 4 pi. So pi and pi is cancelled out. 2 2s are 4. So delta x, you are getting the 2 lambda. And you are getting 2 lambda. Similarly, we will get the 3 lambda and so on. Clear? Now we can say delta x is equals to n lambda, where the value of n is equals to 0, 1, 2, 3 as you will put, you will get the respective values of the part difference. So we can see between the two bright fringes, the difference is only by the lambda. 2 lambda minus lambda, that is lambda. 3 lambda minus 2 lambda, that is the lambda. So when the part difference between the waves is lambda, from one central fringe to, you will get the next bright fringe. It is from the central fringe. Central fringe is always the bright fringe. So from the central fringe, if the part difference is lambda, then you will get the next bright fringe, whether it is this side of the central fringe or on that side from the central fringe. Okay, I hope you can understand. Now we will take the next, that is the destructive interference. For that destructive interference, we will see that where the intensity of the wave is the minimum. So again, from that formula is there, cos phi should be minimum. The cos phi value is -1. We will get -1 when phi is equals to pi, 3 pi, 5 pi and dot 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 dot. We will use that formula for the part difference. If the part difference is x, then putting the different value, we will get pi by 2, 3, lambda by 2, 3 lambda by 2, 5 lambda by 2. How you are getting? I am just showing you. Just you take that, I have written that formula, 2 pi by lambda into delta x. Now put the value of phi. The first value is the pi. When you will put the pi over there, pi and pi will be cancelled out. So delta x is equals to lambda will go that side and 2 will come this side. So lambda by 2. Now if you put the next value 3 pi phase difference, then the 2 pi by lambda into delta x is equals to 3 pi. So pi and pi will be cancelled out. So delta x is equals to 3 lambda by 2. That you got 3 lambda by 2. Similarly, you will get 5 lambda by 2 also, and so on. So now we can see if we are subtracting any of that from the next one, means I am subtracting lambda by 2 from 3 lambda by 2, you will get the difference is that lambda by 2 means, you will get that difference is lambda. How you are getting? 3 lambda by 2 minus lambda by 2. LCM is 2. So then it is the 3 lambda minus lambda, that is the 2 lambda by 2. It means you cancelling the part differences lambda. Clear? So the very first dark fringe you will get from the central fringe when it will be by lambda by 2. And here you can see the phases are pi, 3 pi, 5 pi. The phase differences with that only. When the phase differences by pi means 180 degree, means just opposite phase. Then 3 pi by 2, and again you just go through the 2 pi, so then you will get 3 pi. You will get the opposite phase, and being the opposite phase, the intensity of the light will be minimum, and the power difference between them will be always lambda, but from the central fringe it will be lambda by 2. Lambda by 2 means I am showing you, there should not be any confusion. Means this is the bright fringe. So from this bright fringe to this next one is the power difference from this source and from this source. That should be, the difference should be by lambda by 2. Then this will be. And after that, from this to the next dark fringe, when you will, then the difference should be lambda. Means from this to the next dark fringe, that power difference is lambda. So power difference is always lambda for one dark to the another. But when you check from the bright one, means the central one, then it will be by pi by lambda. Or anywhere from bright fringe, when you will check, so after lambda by 2 power difference, you will get the next dark fringe. So one bright fringe, then the next dark fringe, the power difference for these two will be the lambda by 2, and otherwise from one dark to the next dark you will get the power difference will be lambda. So here you can see that if we generalize and we will convert into the formula form, then we can write this way: 2n minus 1 lambda by 2, and the value of n should be from 1 2 3 4 like that, putting 1 by 1. If you are putting the n equals to 1, 2 1 are 2 and minus 1 means 1 into lambda by 2, the first you are getting. Then when you put 2 n equals to 2, 2 2 is 4 minus 1, 3 lambda by 2. When you putting the 3, 3 2 is 6 minus 1, 5 lambda by 2. So the value of n for the destructive interference case 1 2 3 4, and this will be the general formula for the power difference. And you have already seen key for the phase difference what should be the value of phi. You have seen the pi, 3 pi, 5 pi like this. And for the constructive interference, the path phase difference should be 0, then 2 pi, then 4 pi. 0, the central fringe will be there, and the path difference will be 0, lambda, 2 pi, 3 pi, etc. I hope you can understand. And for the coherent source, as I already said, we are using the coherent sources of light. Coherent sources of light means there is frequency of these, both the sources are same. So we use that for the interference of light. Thank you.